So our journey continues with a deep dive into the intersection of artificial intelligence and manufacturing. Our next guest brings a wealth of experience from over 25 years in the semi-industry. Leading a team of around 800 IT professionals, he supports an ever-growing manufacturing footprint across various segments. Get ready to be captivated by his insights in the role of AI in manufacturing. It is my privilege to introduce to you Didier Chavet, Head of Manufacturing IT Operations at Micron Technology. Your applause, please. Didier? Thank you.
1, 2, 1, 2. Good morning, everyone. I am extremely thankful and very grateful for being here today in front of so many experts. And I'm going to start my speech this morning with a private message to Nicola and Jeff. We have the technology, and Micron is using it. And so I'm extremely excited to show you how we are using it today. The topic of this morning is AI. Extremely hot topic, very difficult. And what I would like to do is to bring it through a 50 years journey to explain a little bit how AI has essentially impacted that journey across industry 3.0 and 4.0. Micron has 13 factories, and we have, as you can see, we generate 13 terabytes of data and 3.3 million of images on a daily basis through AI models. And so this is really an opportunity for us to demonstrate how AI has actually impacted our factory operation. At the same time, Micron manufactures memory product that actually enabled fifth industrial revolution use cases. And so it's kind of being on both sides of the equation. So that's really exciting from that perspective. And so as Jeff was saying, we've gone through 4 revolutions so far. And I'm not going to take you all the way from the 1800. That would not be fair. But what I would like to do is start from the 3rd and the 4th, and at the same time question, where is the 5th revolution? How does it come into place? So let's start with the 3rd revolution. It was called simply the automation revolution. And you can see the ladder with 4 levels: an MES system, a host automation layer, your scheduling, dispatching, and your physical automation. That was essentially, I'm a simple guy, I like to see it very simple, but that was really, and when you see the check mark at the top, it means Micron has gone through that revolution. And so you end up with a very fully automated manufacturing facility. You can see some of our benefits: 50% decrease in new product ramp time, or 18% increase in labor productivity improvement. And I want to show you the real world for just a few seconds.
To date, we're striving for even greater improvements in the future. Let's continue to collaborate and innovate with tenacity on new automation solutions to achieve best-in-class manufacturing for our people and our customers around the globe.
Our factories, our front-end factories, are 95% fully automated. We generate 1.8 billion moves in our MES system per week. That's how automated we are. And so, if you're ready for the next one, it's Industry 4.0. And that's where essentially we called it the digital revolution. And that's where the IoT data came in, the IoT platform came in. And look, especially here, this little running elephant, it's actually passing machine data into your big data platform. And henceforth, you can start to do some interesting reporting, analytical reporting. But we were just scratching the surface at that time. And so you end up essentially with a factory full of sensors gathering all this information. Today at Micron, we have 470,000 sensors across our 13 factories, almost 500,000 sensors. And so this is where I think I've been speaking maybe 3 to 4 minutes. This is where we're going to start AI. This is where we're going to start Industry 5.0. And so essentially, there's 3 phases. The first phase, it actually took place 10 years ago. And we can call it intelligent analytics. That's really the first phase. Capable to analyze a vast amount of data. And it does it through a maturity model that could even go all the way to predictive and prescriptive analytics. And as a result, you can see that both ladder that we talked about, the automation ladder and the digital ladder, went up to 5 levels. Remember that? We used to have 4 levels and 3. Both went up to 5 levels. Especially on the digital roadmap, we can actually do what we call prescriptive analytics. And so essentially, we have use cases. Look at number 3, quality control, or number 5, predictive maintenance. I'll talk a little bit about those in a minute. And so you end up with a step which was fully automated, but now it's not just automated, but also very intelligent. And so you have, as an example, advanced process controls, where one of the benefits is to create a 2% yield improvement just through process controls. So I'm going to bring you through 3 use cases of AI phase 1, which is intelligent analytics. First use case, predictive and prescriptive maintenance. This is, I like to call it, talking machines. It would be like you going to the pharmacy and you tell your pharmacist, I predict I'm going to have a headache. I don't have a headache yet. I predict it. And I am telling you which medicine I need so that I can avoid my predicted headache. So the machine is going to tell you which parameters to change on the recipe so that we can postpone the next predictive maintenance, as an example. The second use case, my favorite, to be honest with you, advanced process control. This is where essentially we've done it for decades in the semi-industry. SPC, fault detection, run-to-run. These are terms for most of you. You must know what I'm talking about. But what has happened with Industry 4.0 is that we have a new stream of data. All the sensor information is coming through essentially an IoT platform, enable you to analyze that streaming information. And sometimes you need to contextualize. Sometimes you need to, synthesize, run a model in the public cloud, an analytical model. And of course, take action, meaning you may have to put a lot on hold or a machine on hold. And so if you can do that across the 4 layers of your process controls, meaning you can do it at the edge, within your traditional process control, SPC, fault detection, or run-to-run, or if you could do it within your data center of your factory, we call the fast data, or in the cloud. If you can run this streaming data platform across 4 layers, you've reached nirvana. As an example, I could send some information from a camera on a machine, and I could decide to pass the information to your local data center in your factory and run your analytical model in the data centers, because you can afford the latency, and then call an API that will take an action on your floor. The second use case, let me go back. This one here, I'm not going to go through the slides. The materials is available to you, but this is really a great slide because it shows the type of information we are expecting at every level of your process controls and some use cases, okay? Next one is the third use case. And this is really a type of information that we are providing through your streaming data platform, most specifically image analytics and video analytics. Look at the splicing operation that's happening here at a pick-and-place machine as an example. We are simply recording what the operator is executing, making sure that it is happening as expected, essentially. All right. It is time now to move to phase number 2. Remember, phase number 1, intelligent analytics. Phase number 2, intelligent robots. And essentially, we're seeing robots that are increasingly capable to communicate with humans and with the environment. And you can see the yellow dot, which is mostly focusing on physical automation. That's where AI2 is going to provide most of the value. Hopefully you follow me. And so the first use case is robot evolution. There's a big difference between what we call industrial robots that are usually leveraged in the automotive industries, and those have evolved to what we call cobots. So they will interact more with humans. On the semi-industry, overhead transportation has always been de facto transportation. It's very efficient, very fast. But in some cases, we have to use what we call auto-guided vehicle. And they have evolved. They have evolved, and they have become automated mobile robots. Some of them have also what we call cobot capabilities. The second use case is, of course, AR, VR. And some of those, as you can see, all these are actually Micron use cases. My favorite is when we can run an SOP, a standard operating procedures, through AR capabilities, and as the operator is actually going through the SOP, we are validating every step of the process through image analytics. And some of the information is so massive that we have to use 5G connectivity. The final use case of AI2 is, of course, a futuristic representation of a factory floor. And it can be questioned because you want to make sure that as you adopt those new technologies, there's value and there's really an ROI in order to accept those futuristic shop floor. type of models. Phase number 3. So far, we talked about Industry 3, Industry 4, Industry 5, which is AI. And within AI, we went through Phase 1, Phase 2, and this is the latest phase, which everyone is talking about nowadays. We would call it intelligent collaboration or generative AI, with immense capability of generating content. And you can see the green dot where it actually provides value to our automation roadmap and our digital roadmap. And the landscape of generative AI application is overwhelming. I mean, we have new applications appearing every day. And so what I'm going to try to do today is, again, to keep it simple for you. We have 3 major groups. The first one would be what I would call the business use cases. And here I'm going to mention only one, which we are looking at Micron right now, is the fact that you could automatically take notes during meetings. The value is great. We often forget to take meeting minutes. You know that. And we often forget, it's sometimes difficult to keep them organized. This is what we're going to try to do. The next one is what we called the factory use case. And here, the one that I really like is the fact that generative AI could, again, take one SOP and generate a checklist of tasks for your operators. And then you can run it through your AR technology, as I just explained before. The third set of use cases are IT use cases. And here, I don't know if you noticed, there's a check mark. We are actually prototyping a solution to generate code and generate test scenarios. This is extremely promising because it could increase the efficiency of our developers by 30%. Of course, any new technology will come with concerns. We need to be careful. Data loss, IP protection, output quality are usually the most common concerns. So we need to go through due diligence, especially with generative AI, which is really the latest technology we're talking about here. So where do we go from here? Where do we go with this phase 3 of AI? Are there any opportunities for phase 3 to actually support phase 1 and phase 2? Actually, there are. Let me give you one example. What could happen is generative AI can provide additional content, context, and explanation to an analytical model that was actually part of AI1. Take an example. You could have, it's a little bit the other way around, but you could have a generative AI model that would create multiple alternatives of a product design, and then you could run on top of that an analytical model that will tell you what is the most efficient and the most cost-effective product design. The next question is, could we expect generative AI to accelerate the development of humanoid robots? Very difficult questions. I don't believe so yet. We could expect maybe in 5-10 years to start to see humanoids, robots in the shop floor, as long as there is value and there is really a fit for this type of activities. What we've seen so far is we are focusing on developing user interface to standardize the configuration of a fleet of robots through digital twin. That's really what we're trying to do in general. So here we are, guys. 50 years. I've gone through 50 years of manufacturing system evolution. This is the full pictures. You have everything right there. We had two major industry revolutions, 3 and 4. We had 3 phases of AI, and I have hopefully, in simple terms, I have hopefully explained the impact of those 3 phases on 3.0 and 4.0. Now, what would happen if you have a green factory, you start from scratch, or you may even have a legacy factory with very old application, and you wish to bring that factory to a level where you could just say, hey, within 6 months, I'm going to go through 40 years of evolution. How can I do that? That's where Micron has decided to implement critical manufacturing or in our assembly and test factories, because we believe that critical manufacturing has tremendous capabilities in terms of system integration and advanced integration, enabling us to move those factories to the next level very rapidly, especially on the assembly and test side. I'm going to, before my closure, I would like to, Adeline, say a few words. Adeline is actually one of my customers. She's actually the head of smart manufacturing for the front-end factories. The audio may not be very clear, but hopefully you can understand what she's going to say. She's going to talk a little bit about AI within our front-end factories.
Effectively leverage AI in manufacturing processes, it is important to ensure proper data collection, integration, and connectivity across different systems. An example of our deployment is our integrated view analytical platform that leverages AI and machine learning auto-diagnostic capability across more than 1,000 production and metrology steps. We conducted automated root cause analysis and corrective action enablement to quickly resolve equipment downtime and process deviation. On top of that, we employ video analytics to process millions of images per day to monitor real-time manufacturing process anomalies. This includes detecting anomaly in the process, as machine learning and AI can sense things that even the most highly trained human personnel cannot always see, hear, or feel. AI can perform these tasks with laser-sharp precision and in a fraction of time.
Thank you, Adeline. In closure, evolution will progress as long as data transmission will increase. And that's where Micron can actually bring value to the industry with our memory products, because we keep increasing data transmission. And so when you look at the quote in yellow that says the future of AI depends on data that moves at the speed of thought, I really hope that this is going to make you think and dream. Thank you.
Thank you, Didier. Thank you for your more tactical approach on this. Thank you so much.